All right, we're going to continue working on proofs today. This is Math 2, Unit 3.3 C, D, and E notes. Today we're going to be covering parallel lines, perpendicular lines, and we'll be also covering bisectors and midpoints. Okay, so let's just take a quick review. Remember, a bisector, if we had angle ABC and BM was a bisector means it cuts this angle in half, creating two smaller and congruent angles. So if BM is the bisector of ABC, then ABM and CBM, these two angles are congruent. All right, and midpoint, if M is the midpoint of AC, again, midpoint by definition cuts the line segment in half, so AM and MC would be congruent by definition of midpoint. All right, we'll start with those and we'll go from there. All right, I believe this one is actually a little bit of a review. So let's take a look at this one. Now remember, what we're doing when we're doing a proof is we're proving that these two triangles over here are congruent. All right, remember, congruent triangles, all of their corresponding parts are congruent, and all of their, which means their three corresponding angles are congruent. Angle A and C, angle ABM would be congruent to angle CBM, and of course angle AMB would be congruent to CMB, and AB would be congruent to BC, and AM is congruent to CM, and of course BM is congruent to BM. Got a little kind of picture of it right here. And we could prove it. We got M in the middle. We could prove that these two triangles are congruent. If we could lift it up off the paper and fold it in half, we can prove that these two sides are congruent. Obviously, these two sides are congruent, and these two sides are congruent, and we can see that their angles are all congruent. Now, that's just kind of a crude triangle example I made, but we can see if we could take C and we could fold it over to A, we would show that all the parts are congruent. When we do a proof, there's always some given information that always puts in the first line. That helps us find other information, and there's always some investigative work we have to do to finally prove that this statement is true. So let's get started. Always some free points available for you in a proof. Usually when we grade proofs, here's a point for each line that's filled in correctly. So M is the midpoint of AC. It's always tough to get this on the first line. And AB is congruent to BC. Okay, so M is the midpoint of AC. Well, that tells us that AM is congruent to CM. I use two lines so that we don't mix it up with this. And we know that AB is congruent to BC, and they already marked that for us. All right, so remember, when we're proving triangles congruent, there are 6 parts, but most combinations work. We need to prove that 3 of the 6 parts are congruent. In this case, hopefully you can see we're going to prove side, side, side. And once I come up with what postulate I'm going to use, I like to write it right here, because I've got to put a check mark above each one of these. So in M is the midpoint of AC, we get these two. AB and BC are given, so this is one of them they give to us. So I'm going to put a check, because we have to write down 3 of those statements, 3 congruency statements. So we got that guy. The next thing we're going to have to put is, how do we know this information? The reason for this information. In this case, this one's given. Those are free points. You've got them right here. You write this down and you put given there. All right, now we can go ahead and we can put this actually in here. What we're trying to prove down here is that triangle ABM is congruent to triangle CBM. So here's 3 points you can get in every proof. Now, we never put prove here. We never put that here. Even though we put this here and given there, we put this here. We never want to put that over here. This goes here. Okay? We're going to eventually put this here. I'm going to write it in now, but we're not done. We have to fill in some more information. So as I said, we have this one already done. Now we're going to say that line segment AM is congruent to line segment MC. How do we know that's true? Well, that's by definition of midpoint. Okay, so now we have our second one. So we can put that there. And now we just have to show that BM is congruent to BM. How do we know that's true? By reflexive property. That's one we use quite a bit. You need to know that one. Okay, there was some given information. Right here, we had to use the information that was given to get to this one. This is the investigative work. We had to investigate and find that BM was shared by both. It's called reflexive property. Now we can say the triangle ABM is congruent to triangle CBM by side-side-side postulate. All right, let's go on. We'll start working through these a little quicker now. All right, so let's see. So we know that line segment PQ bisects angle SPT, sorry about that. And we know that SP is congruent to TP. Okay, let's see what we got here. So if PQ bisects angle SPT and SP is congruent to TP, okay, so it looks like we know that these two angles are congruent. That's by definition of angle bisector. And they share this side PQ, don't they? So it looks like we're going to use side, angle, side. And the nice thing is our first side is there for us. Let's put the angle in now. Okay, but remember this is given. We've got to always put our reasons in. So I'm going to put angle SPQ is congruent to angle TPQ. And that's by definition of angle bisector. And I'll use a little shortcut for angle. Okay. So now there's our angle. We got that covered. Now we just got to show our last side, which is PQ is congruent to PQ. How do we know that? Reflexive property. Okay, we got our third side, check. So now we can say that triangle SPQ is congruent to triangle TPQ. And we know that by side angle side postulate. All right, let's go on to number 3. All right, here's some parallel lines. This is a tricky one for you, but whenever you see parallel lines, you better be thinking about our parallel line theorems. Let's get started. Given VX, line segment VX is congruent to line segment XY. Also given is line segment XW is congruent to line segment YZ. And finally, XW is parallel to line segment YZ. All right, and all that's given. Okay, remember, once we put our given down, we want to go back and put all our information on our picture. So VX is congruent to XY. VX congruent to XY. XW is congruent to YZ. So we know these two. Remember, I used one line for these two lines here to make sure I distinguish between the two. And finally, we know that XW is parallel to YZ. We show parallel with a little arrowhead right there. It shows those two lines are parallel. All right, now here's what you have to remember. If these two lines are parallel, then that would mean line segment VY is a transversal. And this one might be hard for you to see, but it tells us that corresponding angles are congruent. So when lines are parallel, cut by a transversal, then corresponding angles are congruent. All right, so it looks like we're going to use side angle side to prove side angle side. So I write side angle side. Okay, now the nice thing they give us most of it. That's that side, and that's that side. So now all we need to prove is the two angles are congruent. And that's pretty easy. We say angle VXW, we have to name them. Angle VXW is congruent to angle XYW, angle XYZ, sorry. Angle VXW is congruent to angle XYZ. And how do we know that? That is by, we're going to say corresponding angle theorem. Okay, because when two lines are parallel and cut by a transversal, corresponding angles are congruent. Okay, so now we've got our angle. So now we can say that triangle VXW is congruent to triangle XYZ. Now when we create proofs, we always try and give you the right number of lines to prove it, and we know this by side angle side postulate. When I was making up these notes, I pulled this question from an old worksheet, and I pulled these statement reason grid from another worksheet, and that's why we have extra lines here. Okay, let's go down to the last one we're going to do. This one's, we have line segment GH is parallel, or excuse me, congruent to line segment IH. Let's write that down. And hoping we're going to have an extra, I don't think we're going to have an extra line. I'm going to write this one. Normally we try and write the given all on one line, but these are kind of small here, so I'm going to move this down to the second line. So I'm going to probably end up using a fifth line down here. J is the midpoint of GI. So I'm going to put given here and given here. If we can put it all on one line, that's great. Okay, so we know that GH is congruent to IH, and we know that J is the midpoint of GI, which tells us that these two guys are congruent, and they share JH. Okay, so we already are given, it looks like it's going to be side, side, side again. We have that one down. J is the midpoint of GI, so we know that GJ is congruent to IJ, and we know that by definition of midpoint. Okay, and now we know that JH is congruent to JH by reflexive property. Which means now we can say that triangle JGH is congruent to triangle JIH by side, side, side postulate. Okay. All right. So hopefully that helps. Your worksheet that goes with this is worksheet 3.3 CDE. There is a slide on Google Classroom. Good luck.